Right. We started talking about the properties of what? Of matter. Are we together? Right. This is one of our YouTube videos, right? Is it all right? So we are saying everything around us is made of what? Of matter. Are we together? Right. And materials are substances that we use to make things with. Right. So we are saying materials, they can either be what? Natural or man-made. So you have to know that the materials that we are talking about, that we use to make things, they can either be what? Natural or man-made. So if you get a question whereby they ask you natural things or natural materials, you think of things like sheep's wool. It's an animal, right? It's an animal. An animal was not human-made. You understand? It's something that came like through nature. We just found it there. You know that there is ships. No human being can manufacture, but the ships, they can reproduce themselves. Right? So that's natural things. And then we can also talk of cotton. Right? Cotton is a plant. So it's something that is what? Natural. The only thing that a person can do is to plant the seed. But it's something that is natural. But then if we talk of human-made materials, we now talk of things like plastics, nylon, polyester. You see, those are human-made things. You understand?
Yes.
Right. Alloys of materials. So you have to know the difference between natural and human-made things. Right. And then again, you have to know when we are talking of the physical properties of materials, right? We are saying materials, they are suitable for a particular use if it has the properties that are needed in the finished product, right? In the finished product. So we defined what you call compressive strength. Like we are saying materials, they can be strong in different ways, right? So when we are talking of a material like concrete, right? Concrete is very strong, right? That is why even like when we are getting into Cape Town or a lot of roads that have been manufactured here in the Western Cape, you see it's a combination of steel and concrete. So we are saying concrete one, it's strong, and once, right, it dries up, it cannot easily change shape. Right. Once the concrete dries up, you see, those roads, they were made way back. We are now talking of many years way back, but they are still strong. Cars, they pass every day. They don't break up easily, right? So that's why they chose steel and concrete. So we are saying concrete it has got what you call the compressive strength, right? So we are saying materials like concrete, rock, and bricks, they have got what we call a high compressive strength. Are we together? Yes. And then steel, it is also strong in another way, right? Yes. It can resist being stretched. So steel can also withstand tension. So we say it has got tensile strength. So those are some of the keywords that you're expected to know. Compressive strength, that strength of an object, right? Yes. That actually prevents it from being crushed. Are we together? Yes. That is what you call the compressive or changing shape, right? And then when we are talking of the tensile strength, we are saying of the strength of object, right? That prevents or that stops it from breaking. That's the tensile. Are we together? Did you understand those two terms?
Yes, sir.
So what is the compressive strength?
Compressive strength.
Yeah. What did you say? What we said is the strength of an object that stops it from being crushed or changing shape.
Yes, sir.
Did you get it?
Yes, sir.
What did I say?
It is a.
Yeah, you're right. That prevents it from being what? Crushed or changing shape. Don't think of is the strength of the object that keeps it from being what? Crushed or changing shape. That's the compressive strength. And the tensile is the strength of the object that prevents it from breaking. So compressive is not, it's changing shape and being crushed. And this other one, it prevents it from breaking. Are we together?
Yes.
So we have talked about the strength, right, of concrete and steel, right? And then from there, we want to talk about the term flexibility, right? So when we are talking about the term flexibility, you are writing exams this year, right? You have to be able to define, right?
Yes, sir.
You have to be able to define terms, and I want you to study. I want you to improve from last year. We did also a lot of things last year, right? And this year we are also together. So we are saying flexibility is the ability to bend easily. You see, when you hear of someone who is flexible, someone who can bend what? Easily. You say this person is what? Is flexible. Especially those people who can dance, they are what? Who can do break dance, they are what? Flexible. You understand? Even like soccer players, some who are skillful, they are what? They are flexible. Right. So we are saying that ability to bend easily. Right? That's what you call flexibility. So what did I say about flexibility?
Flexibility
Yeah.
is the thing that can easily bend.
Exactly. So don't forget it. Something that can easily bend, or the ability, or is a measure of how easy it is to what? To bend. Right. So we are saying flexible material, you have to know that they can bend without what? Breaking. So sometimes they can say, give an example of a flexible material. We talk of what? A rubber. It's flexible rubber. So we use flexible materials, like I said, for what? Tires, right? For fabrics, for cloth, right? For plastic rulers, right? So from there, right, you now know what it is meant by flexibility and strong. And then now we want to also talk about the boiling points and the melting points of what? Of different liquids. So we are saying when a substance changes from solid, or those, if you see those ice blocks melting to liquid, we are saying they are melting. That's the word melt. So what is to melt?
Is when a solid turns into a liquid.
It's from solid to what?
Into a liquid.
To liquid. So whenever you hear the word, if they say what is the meaning of melting point, you now know is the temperature. Are we together? At which a substance melts as it changes from a what? Solid to liquid. The temperature. And then when we talk of boiling, we are saying when a liquid starts to bubble, right? And change into a gas. That's what you call boiling. And then the boiling point is the temperature at which a liquid changes now to what? To gas. It's now steaming, right? And then whenever you hear the word electrical conductors, right, we are talking of materials that allow electricity to flow or to pass through it. And then the opposite of electrical conductors, we are talking of electrical insulators. These are materials that do not allow electricity to flow or to pass through, right? Those are what you call insulators. And then whenever you hear the word electrical conductivity, now we are talking of, when we are talking of the word conductivity, this is now the ability for a material to allow electricity to move or to pass or to flow through or to allow the charge or the current to what? To pass through. So that's what we talk about electrical conductivity, right? So you see, I'm writing you the notes, the point form, right, you are supposed to also go and reread, right, and also try to rewrite again so that you can understand. You see, the moment that you are going to read and write the notes that I'm giving you, right, you are going to understand it. That's how you start it. You give yourself time, right, you meditate, you start to think all the examples that I'm trying to show up to you. Is it clear? Right, so that's how you understand. These are theoretical subjects. If you don't read them, you can't be able to understand them. So we are saying again, many substances, right? They've got different melting and boiling points, right? So we want to talk about the substance iron. You see, iron, there is steel, there is iron. So we are saying the melting point of iron is what? 1535 degrees Celsius, right? And then there is this other metal, right? Or this other element called lead. You see, we have talked of iron. That is what we call lead. Lead, it melts again at a much lower temperature of 327, right? So that's why we use lead in our electrical fuses. Are we together?
Yes.
Right? I'm sure you know what we say by fuses, right? Even like if you open a switch like the one that we put right on the sockets, there is a fuse inside. Those 3-pin plugs or our plugs for stoves, whatever, they've got a fuse inside. That fuse is made by what? Lead. Because lead, it has got a lower temperature, right? It melts at lower temperature of 327. So we are saying the lead in that fuse, it melts if there is a what? An electrical fault. So if it happens that there is an electrical fault, the lead in the fuse, it will melt, right? Because the wires, it will make the wires become too hot. Again, other materials that we know in our day-to-day life, we know of silver and gold, right? Whenever you have the word silver and gold, think of wealthy. They also have a fairly low melting points. Gold, it melts at 1064 degrees Celsius, right? And silver, it melts at 962 degrees Celsius. So again, this makes them very suitable to use in jewelry. Gold is something that is on demand. There are different uses of gold. We talked about them even like last year. We can use gold to make jewelry. We can use gold to make even like coins, right? We can make jewelry to make even like treasures. Are we together? Right. Those gold bars, we can use gold just as a form of exchange, right?
Yes.
And then to design different things. And then what we are saying when we are talking of copper, again, copper's melting point is slightly bigger than that of gold. It's almost 1085 is different from gold, that is 1064. And then we are saying, again, when we talk of the boiling points, there are some substances that boils at very low temperatures. For example, a thing like ethanol. Ethanol is a type of alcohol, right? It boils at about 78 degrees Celsius, right? And then there is things like, we use salt every day when we are eating, when people are cooking, they use salt. Salt is about 800 degrees Celsius, right? It melts at about what? 800 degrees Celsius. So again, salt is being used in a lot of things. Even in electricity, we can use that molten salt to transfer it. You see those solar panels?
Yes, sir.
Right, for example, we are saying in a concentrated solar power station, the sun's heat is focused, right, on those mirrors. It's focused using many mirrors too. So those mirrors, you know what they are doing inside? They are melting salt inside. Are we together? The heat comes from the sun. It goes to the what? To those mirrors that see on the solar. And those mirrors, right, they are melting salt. So the molten salt, right, is then piped to boilers, right, to produce steam that generate or that turns generator to produce electricity, right? Again, we are saying that molten salt that has been molten at 800 something degrees, right, it can also be stored and used at night to keep generating electricity, right? And the other thing that we can talk about is paraffin. Paraffin is a mixture of different petroleum-based products. So it means like it can have different boiling points starting from 150 to 300. So these are some of the things that you are expected to know. Are you understanding?